Suppose we want to factor an expression where not all the terms have something in common. We would have to use a technique called factoring by grouping. If we look at the expression in our example here, we can see that there is nothing that all four terms have in common. Only the first three terms have an a variable in it, the second and fourth terms have a c in it, and only the last two terms have a b. So there is nothing that all four terms have in common that we can factor out of the expression by finding the greatest common factor of all four terms. The idea behind factoring by grouping is that we would have to group certain terms that have something in common together and factor them individually. We have to group terms that have something in common together for this method to work. So if we look at our example here, we can see that the first two terms, 12a squared and 8ac, have a 4a in common, so we'll put these in a group. And the last two terms, 9ab and 6bc, have a 3b in common, so we'll put these two terms in a group. So the greatest common factor between 12a squared and 8ac is 4a, so we'll factor out a 4a from both terms. If we take 12a squared and divide that by 4a, we get a 3a, and 8ac divided by 4a is 2c. And we'll move on to our second group and factor 9ab plus 6bc. The greatest common factor between the two is 3b, so we'll take 9ab and divide that by 3b and get a 3a, and 6bc divided by 3b is 2c. So we have factored our second group. So if we look at our partially factored expression, we can see that the first term, 4a times parentheses 3a plus 2c, and the second term, 3b times parentheses 3a plus 2c, both have a 3a plus 2c in common. So if we treat 3a plus 2c as a single term, the greatest common factor between the two terms is 3a plus 2c, which we'll take out from both terms. So now, to continue our factoring, we take the first term and divide that by 3a plus 2c, and we simply get a 4a. And if we take the second term and take out a 3a plus 2c, we're left with a 3b. And this is our final factored expression. We can see that this expression is factored because there are no additions or subtractions outside the parentheses, and it's in the form of two polynomials multiplied by each other. Let's look at another example. The first thing to do when factoring by grouping is finding terms that have something in common. The first two terms, 28a squared and minus 12ab, have an a in common, so we'll put these two terms in a group. And the last two terms, 35ac and minus 15bc, both have a c in common, so we'll put these two in a group. So we'll continue the process by factoring the first group, and we'll take out a 4a, which is the greatest common factor, from both terms in the first group, and 28a squared divided by 4a is 7a, and the negative 12ab divided by 4a is minus 3b. So we'll move on to our second group and take out the greatest common factor from both terms in the second group, which is a 5c, and 35ac divided by 5c is 7a, and negative 15bc divided by 5c is negative 3b. So now we can see that in both terms in this sum, they both have a 7a minus 3b in common. So we'll take that out from both terms. And if we take away a 7a minus 3b from our first term, we're left with a 4a. And if we factor out a 7a minus 3b from our second term, we're left with a plus 5c. And this is our final factored expression. Let's do another example. 42ab and minus 35b squared have a b in common, so we'll put these two terms in a group. Minus 18ac and 15bc have a c in common, so we'll put these two terms in a group. We'll start by factoring our first group. The greatest common factor between the two terms in the first group is 7b, so we'll take out a 7b from both terms. 42ab divided by 7b is 6a, and minus 35b squared divided by 7b is minus 5b. So we'll move on to our second group and find the greatest common factor between the two terms in the second group, which is a minus 3c, which we'll factor out from each term. minus 18ac divided by minus 3c is 6a, and 15bc divided by minus 3c is minus 5b. So now if we look at our partially factored expression, we can see that both terms have a 6a minus 5b in common, which we'll take out from each term. So if we take out the 6a minus 5b from our first term, we're left with a 7b. And if we factor out the 6a minus 5b from our second term, we'll get a negative 3c. And this is our final factored expression. So now let's try a slightly harder example. Let's factor this expression with 6 terms. We're going to have to split this into 3 groups. The first 2 terms have an a in common, so we'll put these 2 terms in a group. The third and fourth terms both have a b, so we'll put these 2 in a group. And we'll put 3c plus 1 in a group. We'll see what we need to do with this in a second. So if we factor our first group, we take out the greatest common factor of 2a from the 2 terms in the first group. 6ac divided by 2a is 3c, and 2a divided by 2a is a plus 1. So now we move on to our second group, and we take out a 2b from both terms in the second group. 6bc divided by 2b is 3c, and 2b divided by 2b is 1. So now we're done with our second group, and we're left with the 3c plus 1, which we'll put in parentheses. And now we can see from our partially factored expression that all 3 terms have a 3c plus 1 in common. So we'll take out a 3c plus 1 from each term. So if we take out a 3c plus 1 from our first term, we're left with a 2a. And if we take out a 3c plus 1 from our second term, we're left with a 2b. And for our third term, we can think of 3c plus 1 as 1 times parentheses 3c plus 1. So if we take out a 3c plus 1 from our third term, we're simply left with a 1. And this is our final factored expression. So one thing to look out for when doing factoring by grouping is whether or not the way we group the terms will work. If we look at our example here, we can see that the first 2 terms have an a in common, so we can put these 2 terms in a group. The third and fourth terms both have a c, so we can put these 2 terms in a group. And we'll put the last 2 terms in a group. So to factor our first group, we take out the 3a that they both have in common, and 15ac divided by 3a is 5c. 9a divided by 3a is a plus 3. So moving on to our second group, we can factor out a negative 10c from both terms in the second group. Minus 30bc divided by minus 10c is 3b, and 20c divided by minus 10c is minus 2. We can take out a negative 6 from both terms in the third group, and minus 18b divided by minus 6 is 3b, and 12 divided by minus 6 is simply a minus 2. So if we look at our expression here, we can see that we've run into a problem. There is no expression that all 3 terms have in common. The first term is 3a times parentheses 5c plus 3, but in the second term, we have a minus 10c times parentheses 3b minus 2. So there's nothing that all 3 terms have in common, so we can't take out the greatest common factor of anything from all 3 terms. So this means we have to do our factoring by grouping in a different way. One way to determine whether or not the way the grouping is correct is to check the ratios of the coefficients. If the ratios of the coefficients in each group are not all the same, the factoring will not work. We can see that in the first group, the coefficients 15 and 9 don't have the same ratio as the coefficients in the second group, which is negative 30 and 20, because 15 divided by 9 is not equal to negative 30 divided by 20. Therefore, factoring by grouping with the grouping we used will not work. So if we try a different grouping, we need to find a way to group the terms such that the ratios of the coefficients in each term is the same for each group. If we look at our expression, we can see that the coefficients 15 and 9 in the first 2 terms have the same ratio as the coefficients minus 30 and minus 18 in the third and fifth terms, as well as the coefficients of 20 and 12 in the fourth and sixth terms. They all have a ratio of 5 over 3 in this case, so we can reorder our expression and put them into these groups. So we can rewrite our expression as 15ac plus 9a, which we will put in a group, minus 30bc minus 18b, which we will put in our second group, and our last 2 terms is the plus 20c plus 12, which we will put in a group. If the ratios of the coefficients in each term is the same for all groups, it doesn't guarantee that the factoring by grouping will work, but it at least shows that it might work. So we can take out a 3a from both terms in the first group, and 15ac divided by 3a is 5c, and 9a divided by 3a is a plus 3. Moving on to our second group, we can take out a negative 6b from both terms in the second group, and minus 30bc divided by minus 6b is 5c, and minus 18b divided by minus 6b is a plus 3. So if moving on to our third group, we can take out a plus 4 from both terms in the third group. 20c divided by 4 is 5c, and 12 divided by 4 is 3. So now we can see that we've done our factoring by grouping correctly, because now we can see a 5c plus 3 that all three terms have in common, which we can take out from each term. So inside our second parentheses, if we take out the 5c plus 3 from the first term, we're left with a 3a, and if we do the same for the second term, we're left with a minus 6b, and if we do that for the third term, we're left with a plus 4. So this is our final answer.